Hi, welcome to this video. Our topic is explore the interpolation by using convolutional neural network. I'm Robert from Shenzhen campus. There are two other members in our team, Xiaolin and Zheqi. In this video, I will begin with the process flow of images, how many steps it contains, and then my teammates Zheqi will give a short description about the dataset selection. Xiaolin will present his investigation on upsampling methods. Okay, now let's move on. We know that super resolution is widely used in network image transmission and other fields including medical images and the restoration of old pictures and videos. In this slide, we give all the steps that we have done or going to do. Obviously, from the flow, we need to determine the dataset first. With the original images, we have downsampled it and upsampled it to the original size. This operation aimed at providing input images for the CNN model. We know that the upsampled images are not as good as the original one, and we can get the PSNR to estimate it. And then, with the help of CNN model, we will put the upsampled images, mainly the big ones, into the model and use the mean square errors as a loss function. Say concretely, we need to adjust the big images towards the original images. The model will be trained to handle it. Finally, we will be able to get the optimized images with a well-trained model. And now next step, Zheqi and Xiaolin will introduce us about the dataset preparation and upsampling algorithm we have done.
On the selection of dataset, because we want to make some improvements based on SRCN in order to compare the experimental results, our dataset is the same as SRCN, 91 images as the trained dataset and 35 as the test dataset, and stored in HDF file format. HDF5 lets us store huge amounts of numerical data and easily manipulate that data from NumPy. Python also has H5py to help us easily load and store HDF files. We have learned from SRCN and practiced it. During this process, we also found some problems. For example, the calculation time is slightly longer. We used extremely small loss function and 400 epochs to train. Finally, it takes an average of 6 seconds per epoch. After that, we will consider selecting different optimizers and network layers, such as residual network, to improve efficiency. We also want to change the original bicubic way in upsample part to explore the impact of different interpolation methods on performance. So, in the subsequent experiments, our main direction is to change the interpolation method and the internal network layer. We first use the same network layer to compare the results obtained by different initial interpolation methods, and then use the same interpolation method to compare the results obtained by different layers.
The first is the 16-point ordinary bicubic interpolation algorithm. It is established 16 equations about the interpolation parameters. By solving the equations, the solution of the 16 interpolation parameters are obtained. Our attempt to improve is use only magnitude 3 size interpolation and the value kernel functions construct 16 equations to solve the interpolation kernel parameters. We use the partial derivatives of point AHO to the x direction and the derivatives of CEG with respect to y direction, point phi with respect to xy direction. And this is a follow chart. We use the OpenCV-res function to downsampling at all multiples. And according to the low images of every 9 points to get the final restricted image. And the most common algorithm is 16-point convolution bicubic interpolation. It is used interpolation kernel function. The most important is the selection of the parameters of A. And Keys in his article assumed A is negative 0.5. And the OpenCV-res function set A is negative 0.75. Our attempt is on the basis of the original algorithm. We try to get a more optimized parameter of A. By inputting the training set image through, we designed the loss function. and get optimist values of A. We use the datasets of ResS4 and VID4, and they are offered by Natar 19, an important competition in the field of super resolution. And we prepared to use PSNR and SSIM as an evaluation index. The result we get preliminary experiment is the score of the 9-point B-cubic interpolation algorithm in PSNR is not good as 16 points, but the SSIM value is improved and the visual effect is better. We are coding and doing more experiments.
Okay, from above, we have prepared our datasets and we have tried some methods to downsample and upsample the images. And we also have investigate into the new ideas, investigate in new ideas about how to upsample the images to get a good quality. And also we have go through and run the model for specific images. And the next steps we will try different downsample ratios, and we will also try to improve the big methods and compare it with original big methods. Also, we will try to adjust the model parameters to reach a fast and high qualified CNN PSNR compared with the original ones. And also, we need to perform more experiments with the dataset and to improve our results.